Hello everyone, I'm Chengshuo from KU University. Today I would like to give the presentation of my submission to the late-breaking work, From Virtual to Real World, Applying Animation to Design the Activity Recognition System, co-authored with Sugiura Yuta from KU University. Nowadays, the data-driven human activity recognition system relies on the training dataset, which is collected from the significant signal variation regions. These regions limited the flexibility to alter the sensor positions, and if the positions need to be changed, the system required to recollect the sensory data from the desired position and re-establish the HAR system. Our system proposed a virtual platform combined with a sensor simulation to design a non-vision HAR system. It provides the accuracy as a feedback of examined position via the cross-validation, and the virtual sensor can be tested to check the corresponding accuracy. The user can determine whether to use these sensor positions or not. The classifier interface trained by the simulation signal can also be generated forwarding to the real activity recognition. We establish our system based on the Unity 3D. We input data stream from the Axis MVN system as the motion, and simulated the sensor of accelerometer and distance sensor in the Unity. The HAR system is built based on the virtual dataset. We use the downsampling, the data segmentation, and data augmentation in the development. We conduct the 3 different cases to validate variable accelerometer system for daily activity recognition. Several types of daily activity recognition with an accelerometer wound on the body. We applied 8 different motions in the virtual environment. The user can have customized demand of the sensor position and activity recognized. For example, the user is able to propose the sensor's position demand and the number, and can have the accuracy of the proposed sensor position-based HAR system to determine whether to use this position or not. In second case is the variable distance sensor system for exercise recognition. We can design a variable distance sensor system where the sensor is attached on the lower limbs of an individual. We apply the 3 different exercise motions: heel up and down, squatting, and hip stretch. We use the real distance sensor to recognize the real activity via the classifier trained by the simulation data in the virtual environment. The last case related to the non-variable system. It is a distance sensing system for motion recognition in a bathroom. We first map the bathroom into the virtual environment and install the virtual distance sensor and conduct the 3 different bathroom activity, like washing hands, brushing teeth, and washing face. The distance sensor's data is mapped into a grayscale figure. And finally, we can map the sensor data and position in the real world to recognize the real activity in a bathroom. The result shows that our system can good map the virtual dataset trained classifier into the real world to successfully recognize the real activity. In this study, we proposed the virtual simulation environment to produce the simulated sensor data. It can draw back the position choice to the end user side. The user arbitrarily to place the sensor in a virtual environment. Combined with the virtual sensory, the process of HAR system design can be improved, and it can output the classifier interface to recognize the activity in the real world. Our future work related to the virtual motion generator to generate the more realistic motions in the virtual and combine with the VR and AR technique to design a game with the virtual sensor. Thank you very much.